Hi, this is a video presentation of PBL Group 6. My name is SIRANJEV and my group members are TEOH, Yap Jing, New Zojun, and Muhammad AZWAN Sharif. Now, what is radar? Radar is a type of radio location system that uses radio waves to determine the angle of the radio velocity of objects in relation to a given location. It means that it can detect aircraft, ships, guided missiles, motor vehicles, even can help detect map weather and patterns as well as terrains. Now, my friend here will my friends here will explain what is radar, what is the equation like, and all that on in the video.
A very good day to the lecturers. My name is TEOH, and now I'm going to be presenting the principle of radar. Radar stands for radio detection and ranging. As the name itself suggests, it uses radio waves to detect and determine the range of a target object. A radar uses the principle of reflection. It will transmit a pulse-modulated radio frequency electromagnetic signal to the target object. When the signal hits the object, it will be reflected back to the radar. The reflected signal can then be analyzed and the information about the target can be determined. Information such as the range of the object, the direction of the object, the shape of the object, and even the speed of the object can be determined. So in simple words, the entire operation of a radar is basically the analysis of the signal that is being transmitted and reflected back from the object that is a target.
Hello, my name is Muhammad bin HASNAN and I will present the characteristic of radar. First is power output. Power output is to compare power transmitted to obtain reasonable range and power wanted of the object. Second is pulse length. It actually have two types of pulse, short pulse and long pulse. Short pulse provide greater details while long pulse provide greater range. Third is PRF. is pulse repetition frequency. When a radar transmits its radio signal, it actually transmits series of pulses, about 500 to 4,000 pulses per second. It is to counteract attenuation of signal by atmosphere. The higher PRF means higher range of detection. Last one is antenna design. Antenna design is to provide an accurate bearing in azimuth while providing coverage in elevation to allow pitching and rolling movement of the object. That's all from me.
Here have three equations of radar. The first one, radar range equation. This equation is one of the fundamental types for an only antenna system. This equation is used to calculate the highest radar detection range when an object is assumed to be in the middle of the antenna signal. And the second one, radar cross-section of targets. Radar cross-section is defined as the duration of its effective isotropic scatter power to the incident power density. The radar cross-section depends on the characteristic dimensions of the object compared to the radar wavelength. And the last one, pulse, repetition frequency, and range ambiguities. Range ambiguities is a technique used with medium pulse repetition frequency radar to obtain range information for distances that exceed the distance between transmit pulses.
So good morning everyone. Now I'm going to present my part, which is the type of the radar. Radar can be classified into two categories, which is the primary radar and the secondary radar. Primary radar can be classified into modulated CW radar, which is using the frequency shifting method. In this method, a signal that constantly changes in frequency around a fixed reference is used to detect a stationary object. For the unmodulated CW radar, we have an example, which is the speed gauzes used by the police. The transmitted signal of this equipment is constant in the amplitude and the frequency. So for the pulse radar, we can see from here, yeah, this is the diagram of the pulse radar. And for the pulse radar, we can classify into MTI radar and Doppler radar. MTI radar uses low pulse repetition frequency, PRF, to avoid range ambiguities, while the Doppler radar uses high PRF to avoid Doppler ambiguities. So for the range of the Doppler ambiguities, actually they have a lot of range, so they have the different function. So next is, let's see the application and uses of the radar in the world. First, radar can be used in military, which uses for tracking, detection, and surveillance purpose. Radar can also be used in the law enforcement. For example, police at the highway use radar to measure the speed of the vehicles. The third application of radar is used in space, which is used to track and detect the satellite and the spacecraft. Radar for remote sensing of environment is used to track the motion of planets and the asteroids in the solar system, while radar also widely used in the aircraft and ship navigation. This is to help the plane and the aircraft to avoid the extreme weather and always have a safe trip. The last application is the radar uses in the air traffic controller. This radar is used for the safety to control the air traffic and also used to guide the depart and the landing of the aircraft. So that's the end for my part. Thank you very much.
And with that, I would like to end our video presentation. Thank you so much for listening in. I hope you get some knowledge or information about why radar is actually important in our daily life. And I would like to thank my friends for presenting this part of the video, why electro communication radar is important. And with that, thank you. Have a great day.